Step 7. We should set up recording variables. This adds up a summary to store accuracy of data. tf.summary scalar accuracy merged equal to tf summary merge all. Writer equal to tf summary file writer file location with tf session as session run total batch int length mnist train labels batch size approach range approaches average cost 0 for I in range total batch x batch y equal to mnist train next batch size c equal to session run optimizer cross entropy feed dictionary batch x batch y average cost c divided by total batch test accuracy session run of accuracy feed dictionary equal to x equal to mnist test images y equal to mnist test labels summary sessions run merged feed dictionary mnist test images x equal to y equal to mnist test labels writer add summary approach print entry incomplete writer add graph session graph print session run accuracy feed dictionary x mnist test images y equal to mnist test labels definition create new conventional layer input data number input channels number filters filter shape full shape name conversion filter shape 0 filter shape 1 number input channels number filters weight tf dot variables tf truncated normal convention filter shape standard deviation 0.03 name here mentioned plus underscore w bias tf variable tf truncated normal number filters name and plus outlier defines the output outlier tf nn convention input data weights here mentioning padding same outlier bias outlier tf neural network RLU outlier k size 1 full shape 0 full shape 1 comma 1 strides 1 comma 2 comma 2 comma 1 outlier tf neural network maximum pool outlier k size strides padding same return outlier if name main run cnn following is the output generated by the above code c at tf neural network softmax cross entropy with logistics v2 here output generated by the above code this is the output here if you are saying output here CPU supports instructions that is TensorFlow binary was not compiled to use API system 10% of system memory, exists 10% of system memory, cost 0.0676, test accuracy 0.940, test based off out of memory, allocation exists. See, out of memory going on. While computing. TensorFlow, recurrent neural networks. Next chapter. Recurrent neural network is a type of deep learning oriented algorithm which follows a sequential approach. In neural networks, we always assume that each input and output is independent all of the other layers. These type of neural networks are called recurrent because they perform mathematical computations in sequential manner. That is, consider the following steps to train a recurrent neural network. Step 1. Actually, again, I have to tell neural network deep learning oriented algorithm which follows a sequential approach. Sequential approach. 1, first, second, third, like that. Sequential approach. In neural networks, we always assume that each input, each input, output, input output, assume each input output is independent of all other layers. This one, other layers. That is other layers. This type of neural network is called recurrent. Output, input, different. Each input output is independent of all other layers. Independent, not dependent. Okay. Input specific example from dataset. Step 2, network will take example and compute some calculations using randomly initialized variables. Step 3, predicted result is then computed result. The comparison of actual result generated with the expected value will produce an error. Step 5. The trace the error is propagated through same path where the variables are also adjusted. Step 6. The steps from 1 to 5 are repeated until we are confident that the variables declared to get the output are defined properly. 7. Step. A systematic prediction is made by applying these variables to get new unseen input. The schematic approach of representing recurrent neural networks is described below. Input output total, not it is independent. Recurrent neural network implementation with TensorFlow. In this section we will learn how to implement recurrent neural network with TensorFlow. Step 1. TensorFlow includes various libraries for specific implementation of the recurrent neural network module. Import necessary modules from feature import print function. Import TensorFlow as TF. From TensorFlow, contribute import RNN. recursive neural network. This one. From TensorFlow examples tutorials MNIST import input data MNIST input data read data sets temp data one hot equal to true. As mentioned above, the libraries help defining the input data, which forms the primary part of recurrent neural network implementation. Step 2. Our primary motive is to classify the images using recurrent neural network where we consider every image arrow as sequence of pixels. MNIST image shape is specifically defined 28 cross 28 pixels. Now we will handle 28 sequence of 28 steps for each sample that is mentioned. We will define input parameters to get sequential pattern done. Input n input 28, MNIST data input with image shape 28 cross 28, n step 28, n hidden 128, n classes 10, TF graph input, x TF placeholder plot none, n steps n input, y equal to TF placeholder float none, n classes weights out TF variable, TF random normal n hidden n classes biases out TF variable, TF random variable, n classes. Step 3. Compute the results using defined function RNN. Get the best results. Here, each data set is compared with the current input state, and the results are computed to maintain accuracy rate. TFRN of X weights bias. X equal to TF and stack of X n steps 1. Define a persistent cell with TensorFlow. LSTM, sorry, not persistent, LSTM underscore cell equal to RNN by basic LSTM cell of n hidden forget bias 1.0. Get LSTM cell output states RNN static run LSTM cell X T type TF float 32. Linear activation using RNN inner loop last output. Return TF matmul function of output -1 weight out bias out here plus to be mentioned. Breed Rn equal to Rn of X weights biases. Define loss and optimizer cost. TF that gives me TF neural network softmax cross entropy with logistic equal to predict labels Y. Optimizer TF trade Adam optimizer learning rate minimize cost. Evaluation model correct prediction TF equal TF argmax predict PRED TF ARG max y of y comma 1 accuracy TF predicts mean TF cast correct prediction TF data flow 32 initializing the variables INIT TF global variables initializer. Step 4. In this step we will launch the graph to get computational results. This also helps calculating the accuracy for test results with the TF session as sessions. Session run initialize step 4 equal to 1. Keep training until reach maximum iterations. This is the very important point. Very important point. Point step batch size less than training iterates batch X batch Y MNIST equal to MNIST train. Next batch size batch X reshape batch size n step n input session run optimizer feed dictionary X equal to colon batch X Y colon batch Y